Yeah, thank you very much for the nice introduction, Elisa. Yeah, I would like to give you today an insight on strategic planning for ecosystem services and land management, mostly, to be honest, for projects we have done in the recent years in Germany, to give you an impression, not so much on recent work on land consumption, but I will continue working on that. But for the moment, I thought it fits better if we focus on the ecosystem service side. I mean, I take a lot now a European perspective, or mainly EU perspective, because I mean, that's where I have the most experience, to be honest. In the end, I will try to build a bit of bridge to the Ukrainian situation, but I mean, it's a totally different setting. So still, most of the concepts are valid also for countries outside the EU, but probably future new members. So if we need information on sustainable land management, we need to look on the left side towards the farmer or the other land managers, and on the right side to the outcomes, the positive, negative, and so on. And I symbolize it here now with tractors who fertilize more or less, symbolized by the different balls. And this is, let's say, synonymous for, let's say, land use intensity. And this land use intensity, how I manage my land, probably considering permaculture as a low intensity approach compared to conventional agriculture, which you experience a lot, both in the Ukrainian, but also a lot in Eastern Germany, given the, let's say, communist periods where we have a lot of land consultation and a very high intensification. These are patterns we also observed a lot here, probably not at the really large scale as in the Ukraine, but still quite large. And these managements affect ecosystem services. So ecosystem services are the benefits we receive from nature as a human. For example, regulating ecosystem services like erosion control through cover crops, or water purification through buffer strips along rivers. Then we have cultural ecosystem services, which could be, for example, a scenic landscape scenery driven by water, heterogeneity in landscape, or wide open land. As it depends also on the individual. So it's a bit outside the farmer's perspective, so not probably necessarily a direct benefit for farmers or landowners, but for the larger population, taken often this perspective. And then we have the pure or the major provisioning services on the right side here. For example, like, let's say, crops, or it could be wood, it could be water. So all the things we use as products. And I mean, there is always a link to biodiversity, on which I won't emphasize too much today, but biodiversity is per se not an ecosystem services, but if we enjoy nature, this can also get one. But biodiversity is often linked and may support the provision of ecosystem services. Our common EU application, but also in neighboring countries of the EU, what we do quite often, or why we think it's important to look at ecosystem services, is that we pay a lot of subsidies in the EU with respect to the common agricultural policy. So especially agri-environmental measures. So we assess what is the impact if I support farmers to plant buffer strips, if I support farmers to have catch crops, or if I support farmers to support species such as the red kite through pea windows in agricultural fields, because we have a strong concentration on wheat production in our area here, but we support now farmers co-funded by the EU to implement pea within wheat fields, to have a bit more heterogeneity and to also have feed for many birds, for example, or for, let's say, for the prey of birds, to be honest, if you think about the red kite. And we also need to apply, let's say, the ecosystem or the informational need or ecosystem service concept to the quantitative assessment of spatial planning. So, for example, if we have regional planning, urban land use planning, or forest functions, we really need to quantitatively assess the impact of spatial planning, which we partly do in forest functions in Germany, but which is often quite qualitative in most regional and other land use planning. Yeah, I already talked about the ecosystem services, so I can skip this slide here. But what are the major phases to assess and to plan for sustainable land management? And there are three major phases, which a colleague some years ago identified, which is the most important part in sustainable land management. Like you have a scoping phase, an assessment phase, and an implementation phase. So in the scoping phase, you have to identify first, together with stakeholders, what are, let's say, the major problems, the major issues. For example, you can link it to any land use question. It could be related to permaculture. It could be related to the landscape where you implement permaculture. It depends, and also on the stakeholders who want to have their say with it. And the second thing would be that you have to identify key ecosystem services and beneficiaries. So what could be major ecosystem services we want to address in the planning and the assessment, and who benefits most likely, and whose benefits are probably underrated? Could you already be part of the scoping phase? And then in the third part, you need to check what kind of information do you really need for decision support to improve land management. Do you need quantitative, qualitative information? How spatially explicit do you need it? How much do you need it linked to management or not? The assessment phase, with its 5 phases, that you try to evaluate current land use and its alternatives regarding to ecosystem services. So that's where you start, let's say, calculating ecosystem services, both for the current land use, probably compared to historic land use or potential future development scenarios, but quite often you look at different scenarios and which option provides better ecosystem services. And then you try to see who benefits from ecosystem services and where does it go? Is it regional people who benefit? Is it large scale? Is it the global market? If we think about the current situation and the major issue of exporting cereals from the Ukraine to Africa in the past months, we think, okay, that's a very large area that could be affected from agriculture side, or it could be a very small one, probably permaculture, more focusing on the regional or local demand even. So this is also important. Also, how do these different ecosystem services are different scales? And then the thing would be, how important is biodiversity and ecosystems, or the stability of ecosystems? And do they support ecosystem services, and how can it go hand in hand? Because we do not want, if you look at ecosystem services, totally ignore biodiversity, which is quite often a counter argument. And then I already touched this before, where is the ecosystem service going? Where's the flow? And what other impacts do I might have beyond land use and ecosystem services? So to make it also, let's say, a potential tool linking to people looking at the social impacts, for example, of land management and land management policies. And the last, and probably one of the most important things is how can I synthesize it for decision support, really to provide an added value and to have it taken up by policymakers or other stakeholders. Could be also simply farmers. If farmers take it up by their own, even better than having to go through the policy. I just will show some examples to give you an insight how it can be done, how it's somehow done. This is a recent or a past work looking at the funding policy of the Common Agricultural Policy in Germany. In Germany, we are federal country, so it says, okay, we look at every federal state. It could be Bavaria, where the Technical University of Munich is. It could be Saxony-Anhalt, where I'm located now, or it could be here, Baden-Württemberg, also where in the southwest of Germany. And in every of the federal states, you have to check what do you want to fund with the Common Agriculture Policy. And there with different stakeholders, we identified in a very, let's say, broad format what could be relevant ecosystem services, what could be relevant benefits we want to have from the Common Agriculture Policy. And there the stakeholders identified that we should environmental and ecosystem services be priced or coupled to the production of agriculture products. So we should consider them as somehow as co-benefits and also consider them in our planning of the policy. So really in practical policies, we should assess these. Yeah, just some images where we kind of did this process. But I mean, I said, okay, I did not only work in agriculture, also in forestry, but the techniques are not so different. That's why I show you a local example now from the forestry side. We will jump back later to agriculture again, but just to give you an impression of what can be done and how. In this paper, we looked at the city forest of Augsburg, which you might see here. Augsburg here is Munich, which most of you likely know. The location in Augsburg is also in southern Bavaria. And we have this red study area. These are both communal forests, so forests owned by the city. And we checked which ecosystem services can we bring through proper forest management there. We compare two forests, a large one, which is linked to the city here, because the city of Augsburg like 300,000 inhabitants. So in the urban area, it's a different thing. I think we'll hear also from Monica or from some other people a lot more about the urban side of sustainable land management, but we look at the forest side here now, and the one rural forest as a comparison here. And what is an exercise you often do, which looks like an exercise, but which is a task you can do for any kind of study, if you look at ecosystem services, and which is important, is that you really have to have your stakeholders there, which we have in the pictures, and we ask them, what are major ecosystem services? Which ecosystem services go together, and which do you think are important, could be highly ranked, which are not important? And you can do it as a simple pen and paper exercise to involve people, and not only to involve them in the planning, but also to raise awareness. And they quite often know quite well already many synergies and trade-offs between different ecosystem services and for different land use options. And this could be then the priorities for your analyses. And it's good to take many people on board and to involve more people, that you also have legitimacy for your future studies, and also that you have a high acceptance of your results if you already started involving the people from the beginning. We did this for both forests. We had this urban forest, this bigger one, and this rural forest, and we had, I don't know, forest people like forest managers, forest owners. We had people looking at recreation, so some kind of clubs, sports clubs, and so on. Then we had wood industry, we had urban planners, because the forest is also an important part for urban planning, for local recreation, for urban cooling, and so on. And we also had other users like mushrooms, games, honey as a hunter's game, and also nature conservation and water protection agencies. So we had all the, let's say, major stakeholders to decide where are the ecosystem services mainly produced, and then they had to draw on maps as a scoping exercise. And then we asked them, what are major ecosystem services? On the left, you see here different ecosystem services, and on the right, the colors show which stakeholder groups rate different ecosystem services. If you look at, for example, recreation is the most important ecosystem service and raised by many stakeholder groups. It shows also that other stakeholder groups who are probably not totally into recreation, like nature conservation or forestry, or so they also say recreation is an important service. On the other hand, for example, in this forest, timber, which you would expect very important, is not so high. For example, mediation of climate and water or biodiversity are rated much higher. So it depends on the local situation, just and also that there is an acceptance for the prioritization you want to push in an ecosystem service assessment. And then another thing is how, let's say, balanced do different people rate ecosystem service, or how differently do they rate them? For example, if you look at recreation, people, they rate recreation. Here's a stakeholder group, the color is the service, they rate recreation highest. That's obvious. But then we have the forestry people, and the forestry people have a totally different perspective. They rate all ecosystem services shown here quite balanced. So that's why I said it's very important to have this broad set of stakeholders in this process. Because if you don't, you might have a, let's say, torn picture or a skewed picture there, or biased picture, which you should avoid. Or for example, nature conservation people, they even also recognized recreation is important, but sure, I mean, biodiversity was still more important for them. But you see, forestry people have a take balanced perspectives, and that's also what we need somehow for farmers. But now we come to the assessment phase. What is a way to create different land use alternatives? As one thing we did in the past, and which we'll also do in a new project, but I mean, it's not so advanced that we could show proper results here now yet. I will show a not so recent project. And we made farmers decide what are the land use alternatives. So we can either have willow or poplar here on the left, we can have cereals here, or we can have other crops over there. Farmers can decide on fallow land. And we made them decide, depending on the soil quality, on selling points for the products, such as the wood or for the crops, to decide where would they produce which crop. And then we received different maps. This is one study also in Eastern Germany and Saxony in the Mulde watershed. And where there we looked at how do these willows grow, because willow is an alternative land use option to increase the wood share of wood in a highly agricultural landscape. Because if you look at the map in yellow, all yellow is agriculture. And we have forest just in the southern part, which are the highlands or the mid-range highlands here as well. And you see mostly agriculture. And what we want to see, how would farmers take up short rotation coppers, so willow. And this is this light green here and here. And if we let the market run, there will be standard demand for wood, but the standard demand, you see hardly an uptake of such a practice, and here as well. And this is something, a pattern you might also see for some permaculture. If you just let it for the market, you will have just a very low uptake and probably not such a high impact. So you might need to have more measures than that. Then we said, okay, the price for wood increases here, so we have more uptake in the northern and the southern part, but you have a concentration, so you concentrated here a lot and here, but in the central part, you hardly have it. So in the central part, you will hardly get any short rotation coppers because you have very high fertile soils and simply economically not viable for the farmers. So just to show you how you get these alternative scenarios. So we simulated how farmers decide. And what we thought is the most interesting component there is to see what could be the trade-offs for the different ecosystem services in the different scenarios. If you look for the yield of the short rotation coppers, so the wood yield, we could use for bioenergy, whatever, we have in the baseline, we have no yield because we hardly have it established and want to check whether it will establish. Then we have a standard demand, so hardly a change in yield. And we have an increase, let's say, a medium demand or a high demand and so on, a very high demand. But you see the demand changes a lot towards the baseline scenario. But some of the cereals decline also a lot, probably not as much as the short rotation coppers yield increases relatively. But for example, phosphorus export is hardly beneficially affected. If we allow the market to, let's say, implement this beneficial management practice, because it will not be necessarily established where it's the most effective. So you have a very low effect on phosphorus retention in these areas with the short rotation compass, not only by the sheer amount, but also by the location at the landscape. For sedimentary export, it's a bit better, but if you want to have a realizable effect, you would really have to implement it at a very large scale. So it's also not so beneficial. And then would be the question, how do I get farmers, or how do I get people to really plan more where it's more beneficial? But with this study, we could show somehow, even if we really have a high diffusion of this short rotation coppers, we have not the effects we want, simply because it's probably not at the right locations. Now we continue with the flow. I jumped over some because we are a bit short in time, but they look at the flow of ecosystem services, which is also important to consider. You have different types. So if you look at the supply, now before it was a bit of supply and demand combined, but you have a supply location, which is mine with S, and beneficiaries are with B. And you have different ecosystem services, which are omnidirectional. It could be timber, it could be crops, it could be vegetables. So it's not so linked to the production location. Then you have directional benefits that go in a specific direction from the place of supply. It could be noise reductions through wood structures. It could be erosion protection. If you have buffer strips along rivers, because it stops the erosion to go into the river. You have in situ benefits, which you really benefit if you're on the place of supply, such as recreation. And then we have diffuse benefits, for example, like environmental education and so on, because you don't know where it's exactly going. So supply is often rather clear. Where is the demand, who benefits? It's much more effort to detect this, but it's also important if you want to have a say and an argumentation towards managing for ecosystem services, you need also to show who's benefiting and in which amount. For wood, here one example, if you look at this wood example, you can do it with any crops, but we had this wood example in the study, that's why I use it. We have on the left the urban forest, and you see most of the wood is going to a radius of 100 kilometers. And it's, yeah. And on the right side, it's more, but still mostly going in this 100 kilometer radius. The bigger the bubbles, the bigger is the amount. Simply it's to show that. And also a bit of visualization. What we did at this point is to somehow show how many people can benefit really from the material or energetic wood produced, really benefit. And if we did not, let's say, sell it to other locations, just the people living in these little circles would really benefit from the wood produced. So this forest just produces wood for so few people if you have a standard wood consumption. In the urban forest and the rural forest, it's a bit bigger, simply because, I mean, the population density is lower, but also the wood yield is much higher. It's like nearly 3 to 4 times as high as for the urban forest. But because it's managed for wood production, it's a spruce forest. This is more, let's say, a floodplain forest, not so intensively managed. And for energetic, it's these people living here, but just to show how is the import dependency also of people. If we have the flow and the use area, we could also show what is the difference if we have forest or no forest in the area. Here we see if we replace the forest through agricultural land or cropland, not agriculture, also specifically cropland. Red says there is, let's say, higher sediment export, so hardly any impact, just little impact on the sediment export. So this forest is not very important for sediment retention. On the other side, this forest is very important, and the sediment export increases a lot overall in the shown area here. So this one is important, the other one not. So we just run the model with 2 scenarios to show in a simple way the opposite. So now we come to the synthesis implementation phase. If you look now, will also be soon finished just for the time planning. One thing is what we quite often have in the EU for the implementations, that we really look at these things to evaluate whether our funding for the common agricultural policy is really efficient. That's one study we did in Bavaria, and we checked how is the erosion. Sorry, that's in German. It says just average erosion on agricultural land on different communities. This is a high agriculturally used area with a lot of crop production. Here is more grasslands. That's why here's not so much erosion. Here is more cropland, although in the Alps you would expect more erosion, but here's a cropland area. And then we checked non-funded, let's say, companies are the bluish ones or farmers, and the grayish ones are the funded farmers. And the funded farmers had considerably lower erosion than the non-funded farmers. So we checked, does it have an impact on the erosion produced by farmers? So we compared the funded, the unfunded ones, and see, is the policy effective? So is this payment for ecosystem services working? Because most of our agri-environmental policies, many are payments for ecosystem services already much before the term evolved, like 10 years ago. We already had it before. Yeah, and then there is always this perspective, farmers versus societal costs. So if you have contractual nature conservation programs, also part of the rural development programs, here now a study from Northern Bavaria, close to Thuringia, we looked at, let's say, contract nature conservation. And here we see we have cropland, we have grassland, and we have, cropland and grassland mainly. And then we see what are the different ecosystem services also in money values. Here we says from plant production, also crop production. So you have on intensive land, you have higher than extensive cropland, and bluish means grassland. So the less intensive, the less benefits economically. On the other hand, you have less nitrate towards the groundwater, which is good. The less intensive, the better for the nitrate. So you reduce the negative externalities and negative costs. Then you have like erosion, less costs for erosion, less intensive the things are. And Then you have also the costs for, let's say, flooding. So you also have costs that you produce for flooding for very intensive agriculture. So that's why we wanted to show, okay, also not only what are the benefits, that's because we have on the one side the benefits, and then we have the regulating ecosystem services, which are often negative from agriculture. So you have nitrate to the groundwater, you have erosion, you have different degrees of, let's say, infiltration if there are flooding events. You're more intensively managed, often due to flooding events, you don't have a good infiltration rate. Yeah, and then there's also something about carbon sequestration, which is also to some extent happening by both cropland and grassland. Just how you can put also an economic balance. And then the last thing is that we quite often put it into synthesis. We have like federal things. So we have, for example, a forest report where we put our results in to give it to the wider public. But also, I mean, quite often people contribute to this regional assessment report, for example, on biodiversity ecosystem services for Europe or Central Asia, where we kind of show our results in a synthesized form, like 300,000-400,000 scientists who want to give the policy something to do towards biodiversity and ecosystem services. Yeah, and I mean, you can do this regional studies, and just wanted to the last two things, kind of national studies, where we looked at Germany. Here, for example, northern Germany, we had many more ecosystem services at a regional scale because we had a lot of flood protection and wind erosion and all these services in agricultural landscape, or also in the hilly mountainous areas. And we have very few, or we found much less historically, which are cited as very important here in the northern areas. And also, if you look at grid cells, we have a higher diversity more towards the coast, where we have, historically before 1950, before land consolidation, a very heterogeneous landscape, and we benefited a lot from, let's say, regulating services, fire, flood, and so on, wind protection, which was not so pronounced here in the southern and in the eastern part. Yeah, and then I wanted to show you one result of this IPBES as a World Biodiversity, let's say, report, International Panel for Biodiversity and Ecosystem Services, where we also found results for the Ukraine. And here you see that you're very good in the Ukraine, for example, as well as in Poland, Lithuania, Czech Republic, and managing your agroecosystems still. So it's very important to continue this effort. So it's in a report or result 2005. So it might have changed a lot, but this is something very important, which is also not so well done at some point in Latvia, Estonia, or also Russia, or also Czech Republic, who abandoned a lot the management of agroecosystem, meaning buffer strips or also hedges and so on. And also the cessation as the stopping of the management is an issue, but which you have to target a bit. As I mean, it's worse in Belarus, Russia, but it's better. The stopping stopped a lot in Czech Republic, Poland, Lithuania, Latvia. But this is something you have to work on, which probably is also somehow a goal at some point following up this week. Yeah, and there we are at the end. The last thing, I will not explain too much. There is a game where you can change the language. It's in English, German, and some more language. Just you can choose a language of your choice, and there you can do your own land use planning for ecosystem services, for biodiversity, quality of life. But this is something I leave to you. I won't do that now because of the time, but this is something some colleagues at some years ago developed, which is quite nice to plan and to see the mechanisms for land use planning. Thank you.
Thank you very much, Markus, for the presentation. And I will take over from Lisa and would now be ready to take up any questions for Markus. Pablo has already posted the link again to our sheet where we can drop the questions you might have, and I can then put them forward. And if you prefer that, you can, of course, also directly ask your questions to Markus.
Can I ask a question now?
Sure.
My question is as follows. Do you have any methods or solutions to restore, revive the soils which are too saline, the level of salinity is too high?
Yeah, there are methods, but to be honest, I'm not an expert in soil science. I mean, we have a colleague working on that, but we try now. I mean, we have an issue with salinity from I'm missing English term for mining, because we have a lot of post-mining activities for salt, and we try now to work there, to be honest, now with salt tolerable plants. But I'm not an expert on soil remediation, so I cannot tell something on that. But if we come from a nature conservation side, we try now more to put, let's say, plants that can tolerate more salinity. But soil remediation, you would need to ask somebody else. I'm sorry for that.
And maybe can I ask my questions meanwhile?
Sure.
My question is, how do you link the needs of agroecosystems in provisioning ecosystem services with capacity of natural and regional natural and semi-natural habitats? I mean that, of course, like this assessment which you did, it's a good tool, but I think that it's based on a subjective evaluation by your stakeholders. I'm referring, for example, to Ukrainian situation that we are cultivating a lot of energy crops, especially sunflowers, rapeseed, and they're quite concentrated in a certain area. So, for example, I had an experience cycling for 3 days in the eastern Ukraine, and everything I saw, it was only sunflower, and it requires a lot of pollinators, and farmers could simply just not realize this. So is there any tool to prove farmers that they need that level of ecosystem services and they need to support establishment of some semi-natural habitats or set-aside land?
Yes, I mean, this is what we did. I mean, we did not look at pest control so much or pollination in this study, but in other studies. And that's what I wanted to show. We had the same, not the same, but a comparable situation. We had a lot of maize in this area here because it's highly fertile soils. And in the area where I work now, we have just wheat mostly for the world market because the soil is so good. And the same here with the maize. And we had this concentration. And that's what I wanted to show here is like the farmers in the central part of the study areas would hardly by the market take up, let's say, semi-natural elements like, for example, willow, poplar, whatever, or also hedges. They won't take it up. But what I wanted to show here, because they don't take it up at the right locations, in the intensive part, you don't have any benefit in ecosystem services like phosphorus export reduction, sediment export reduction. So they lose soil because they don't put it to the right location. And something else, I mean, what we found in a study, there are studies that show a lot, if we have semi-natural elements like hedges, the yields also increase within the fields if we have hedges nearby. I mean, they lose land, but on average, there are, let's say, now, which I didn't show here, but there are new remote sensing approaches which show that the yields also in large-scale agriculture, for example, in the US, really increase if we have natural elements around. As you can show this or detect it now with remote sensing now. which we didn't do here, but here we could also add a model on pollination or on natural pest control. And here we could also show, we didn't put a scenario which would be ideal. Where would be the ideal location of, let's say, the semi-natural elements that we have higher benefits for these ecosystem services and also for the farmer-oriented ones like pest control, which we want to do now or which we start soon in a new project here in the intensive production area in Germany. But one approach, simple one, going for the yields is using remote sensing. I can also share some papers on that exist that shows that these semi-natural elements really add to the yield, for example, as a really simple thing, but which normally most farmers accept.
Thank you very much, Markus. And we also had the request that if you are willing to share your papers with us, it would also be nice to share them with the Ukrainian channel later on.
Yeah, I can share what I don't know, Ori, as my personal ones, you can also take from ResearchGate directly.
Yeah, we will share that with participants.
Yeah, this you can probably, it's easier.
Yeah,
because
that's a good idea.
Yeah.
Stephanie, if you could keep please your microphone closer because you are hardly heard.
Okay, is it better this way?
Yeah, much better.
Are there any more questions for Markus in the room? If not, I propose that we could continue with our next speaker if he's already ready for that.